Hello and welcome to our lesson on leading up to quadratics, how to factor with numbers only. First thing, let's talk about a definition. A quadratic is an equation, so there is an equal sign, and it usually has three terms. It's written in the standard form ax squared plus bx plus c. A, b, and c are going to be numbers. X squared and x are just x squared and x, and then it's going to equal 0. In order to be able to use quadratics, you have to know how to factor first. So, finding the coefficients and variables that are multiplied together to create a quadratic equation is what you have to do to factor. Factor means you multiply things. Factoring with numbers only, in order to do that, you must determine if it's prime or composite. That's a big help for you. If it's prime, that means it only has two factors, and if it's a composite number, it has more than two factors. So some examples of prime numbers would be 1, 7, 11, 19, 23, those are all prime numbers because if I break them down with a factor tree, only one and that same exact number are going to be the ones that get multiplied to create that number. Composites, however, are numbers that you can break down multiple ways. 4, 2 times 2 and 1 times 4 create 4. 6, 2 times 3 and 1 times 6. We can do 22, 2 times 11 and 1 times 22, and they keep going. Now, just because it's an odd number doesn't mean it's a prime number. 9 is a composite number because 3 times 3 and 1 times 9. And likewise, just because it's odd doesn't mean it's prime only. An even number can be prime. 2 is a prime number. You can only create it by multiplying 1 times 2. So, in arithmetic, regular math, the way that you multiply two numbers together to get 24 would be like this. You would say 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. So we would say we have factors of 24, and they are 1, 2, 3, 4, 6, 8, 12, and 24. And I listed them from smallest to greatest. That becomes helpful later. Is this a prime or a composite number? It would have to be composite because there are more than two factors. In fact, we have 1, 2, 3, 4, 5, 6, 7, 8 factors for the number 24. Now we need to find the factors of 31. Start with 1 first. So do 1 times. And 1 times what? 1 times 31. 2. Can 2 go into 31? Nope. How about 3? Nope. And you keep going down. It turns out that the number 31 is prime. So your only factors for 31 are 1 and 31. That's it. If you only have two factors exactly, it's a prime number. Let's take a look at another one. Find the factors of 75. Okay, start with 1. 1 times 75. 2 can't go in because this is an odd number. How about 3? 3 times 25. You have 3/4, you have 75 cents. And then 5 times 15. So then we need to list them. Turns out we have 1, 3, 5, 15, 25, and 75. And all of those are factors of the number 75. Are there more than two factors? Yes. So that means we have a composite number. So to double check to make sure that your answers are correct, you simply multiply them. Look at your times tables. So if you think the factors of 24 are 3 and 6, is that right? Is 3 times 6 24? No. So 3 times 6 is not a factor of 24. However, if you write 3 times 8 or 4 times 6, those would get you up to 24. It's a simple recheck on the multiplication table. So for a quick review, in order to use quadratic equations, first you know how to factor, which we just went over. Factoring is finding a set of numbers, sometimes we include the variables too, that can be multiplied together to create the bigger number. Using a times table gives you the factors of a number, but not the factors of a variable, so you'd have to list those out on your own. Remember, for composite numbers, there are more than two factors. And that's it for our lesson on leading up to quadratics, how to factor with numbers only.